myself, Dr. T. Sudarshan Ramaperumal. Today we are going to see about the wireless LANs. So first we are going to discuss about the architecture of wireless LANs. In wireless LAN, the media is air. The signal is generally broadcast when host is near wireless LAN communicated with each other. They are sharing the same medium. And host in a wireless LAN, the host is not a physical connected to the network. It can move freely and can use services provided by the network. So isolated LAN, a wireless isolated LAN is called as ad hoc network. In wireless LAN technologies, a set of hosts that communicate freely with each other. The concept of link layers which does not exist in ad hoc networks. So here we have the wired isolated LAN and wireless isolated LAN. In wired isolated LAN, we use all the hosts will be connected to a switch. In wireless isolated LANs, we have each nodes will be freely connected each other without having any switch. So characteristics of wireless LAN. So attenuation, interface, and multipath propagation. So in attenuation, the strength of the electromagnetic signal decreases rapidly because of the signal decreases in all directions. Only a small portion of it reaches the receiver. Interface: a receiver may receive signals that not only from Indian senders but also from other senders if they are using the same frequency band. And multipath propagation: a receiver may receive more than one signal from the same sender because the electromagnetic waves can be reflected back from obstacles such as walls and grounds. The result in the receiver receives some signals at different phases. This may lead to signal loss, aggregation, error. With the above characteristics of the wireless network, we can accept that error and error reductions are more important in a wireless network than the wired network. IEEE 2.11 is a major specification of the wireless LAN. The standard defines two kinds of services: basic set services and extended service set. In basic service set, IEEE 2.11 defines the basic service set as the building blocks of wireless LAN. A basic service set is made up of stationary or mobile wireless stations and an optional central base station known as access point. This is a simple BSS. First one is the infrastructure-less BSS and another one is infrastructure-based BSS. In infrastructure-less BSS, we don't have any access point, or in infrastructure-based BSS, we have the access points. And then we go for the extended service. Extended service is made up of two or more BSS with an APS. In this case, BSS are connected through a distribution system which is wired or wireless. The distribution system connected in AP is a BSS. IEEE 2.11 does not restrict the distribution system. It can be any IEEE LAN such as Ethernet. Mobile and stationary mobile. The mobile stations are normal stations inside a BSS. The stationary stations are AP stations that are part of the wired LAN. Then it's a simple example for ESS. In a standard service set, we have more number of BSS, so we enlarge our network service. Station types: IEEE 2.11 types, 3 types of stations based on their mobility in the wireless LAN. No transmission, BSS transmission, ESS transmission. A station with no transmission mobility is either stationary or moving only inside BSS. A station with BSS transmission mobility can move from one BSS to another, but the movement is confined inside the ESS. A station with ESS transmission mobility can move from one ESS to another. And max supply: IEEE 2.2 max suppliers, a distributed coordinating function and point coordination function. The below figure shows the distributive cooperative function and point coordinating functions of the max suppliers. It is a portion of the data link layer. Distributed coordination function, one of the two protocols defined by IEEE 2.11 at a max supplier, is called as distributed coordinating function. DCF uses CSMS access method. Before sending a frame, the source station sends the medium by checking the energy level at the carrier frequency. The channel uses the precedent strategy with back off until the channel is ideal. After the transmission found to be ideal, the station waits for the period of time called as distribution interface phase. Then the transmission station sends a control frame called as request to send. After receiving RTS, waiting for the period time called as short infrastructure space, the destination station sends a control frame called as clear to send. The source station sends a data after waiting amount of time equal to SIFS. The destination station, after waiting amount of time equal to SIFS, sends acknowledgement to this to show the frame has been received. When the station sends RTS frame, it includes the duration of the time that it needs to occupy the channel. The stations that are affected by the transmission created by timer is called network allocation vector. Each time the station accesses the system and sends RTS frame, another station starts their network allocation vector. Thank you.